I would like to introduce our next session. Our next session is titled Future Outlook on Emerging Tech for Digital Engineering. We are seeing an increased convergence of physical, digital, and virtual worlds. We are seeing that digital engineering is reimagining the paradigm of how products are being developed. And what we have witnessed so far is just the tip of the iceberg, and the potential that exists is massive. We have with us Sophia Vesigai, Chief Product Officer and Senior Vice President at Aptiv, giving us a detailed context on this topic. As a part of this topic, she's going to discuss about how do we manage data, manage risk, how do we optimize costs associated with operations and maintenance, and finally about sustainability. Thank you.
So can everybody stand up for a second for me? All right. It's great to have you engage and so forth. Shake your hands out. And then sit back down. It's a technique that I learned in Apple. Every time before a brainstorm, we make sure blood is going through our brain. It always helps with movement. So I just wanted to do that. So thank you everyone for attending. We're here to talk about leveraging digital engineering for that safe, green, connected that can influence how mobility happens. If you go to the next slide. So one of the things that Aptiv is very focused on is providing all of the different autonomous features and AI capabilities that's needed to have that safe, green, and connected vehicle, whether it be a car from trucks to fleet management to the cars that you drive here in India. We have a global footprint all over the globe, but with concentration in Bangalore right here. One of the things that we saw at Metatrend from McKinsey and beyond is the fact that there are vehicle fatalities and accidents that's happening. So what can we do in the safety aspect of things to make it even better than before? We know that 94% of the accidents that you see here are because of human error. And there are things that AI, especially with autonomous feature at its core, can go address that. And that because of this, in addition to tens of thousands of people dying from the various accidents, we have 1.2 million accidents that's occurring. Another thing to be mindful is how can we be green and also leverage advanced technology in order to achieve that. Electrification is something that we're seeing across the world, and there's many advancements here in India as well in the technology that's incredibly important for EV technology. And lastly is the aspect of connected. What does that mean? A lot of people think about the various mobile devices that we have here, but it's part of that can be expanded to our vehicle, as well as the connected home that we have in our home. Can we bring that, in the connected office, can we bring that into the vehicle itself and adding the additional mobility associated with it? One thing that I'm very proud of at Aptiv is that not only do we have the brain itself, but the connected nervous systems that's needed. And the reason why it's important to have the nervous system is because we get the various signal that's needed to understand what is actually happening in the vehicle and the people, whether they're in the car, around the car, or remote. So Microsoft actually has this concept of a digital twin really enables the digital feedback loop. Digital twin, it was first originated in NASA in 2010. What that is the virtualization of the physical world in a virtual environment. And the reason why that's incredibly important in autonomous vehicle and mobility in cars is that now we have a system that can have a digital feedback loop. And we can simulate those situations in a virtual environment to de-risk actually trying to test it out in the real world. Like if you had a child, you don't want to test out what would happen if a child suddenly comes in front of you. That is something that is a realistic scenario, but we need to go also ensure that the autonomous features and the systems that we have takes that into account and takes the correct actions accordingly. So how can that be done? The concept that Aptiv especially embraces on the digital feedback loop is how do we engage the customer? And the customers are the various OEMs, the car makers themselves, the end users, the drivers or the passengers, and the people that surround our society and our community. It's empowering the people, the talent that is in our teams, in the various companies to understand what is going on with the autonomous vehicles that we have here and the cars with those features. It's actually incredibly helpful, as well as cost saving, as well as performance in the way we can optimize operation. I will have some examples to talk about that further. And then because we have this feedback loop, we also now have a signal to understand what can be done to the product itself faster than ever before. Instead of waiting for a report to come out from a newspaper or a complaint to come out, that can be months in the making, we can actually start getting data about how the vehicle is being leveraged by you and myself on the road, and then determine what are possibilities, what are maybe early indicators, not try to troubleshoot after the fact. So one of the things I want to be very mindful about is about simulation. One of the great things here is we collected data in the real world. We're able to then leverage the information, any information that's, you may have heard of the mother of all road tests, for those who are in automotive, where literally cars are driven million miles around the world to go collect that data. But what if you want to have that data on the German highways, but in a rainy situation and there's no rain, there's a drought? What are you going to do? Are you going to just wait? How long are you going to wait before it starts raining, right? So those are the scenarios that's real life that car makers are trying to address and understand. So what has happened is I have a simulation team in Active that collects real data and then creates a simulated world associated with it. And the perception system that's used is a combination of both camera, computer vision, radar signal processing, in order to interpret the world that we have here. And so what you're seeing here is by leveraging those two sensors of data, we can perceive the world not only in the situations that you and I can see in great lighting position and so forth, but the times when it's very, very challenging for both of us, for all of us, to be able to perceive what is happening outside of the car. Such as if it's cloudy days or fog or low light, as an evening happens. I don't know about you, I have two boys and they play all hours of the day, and even at night or where there's low light, they're still playing. Those are scenarios that's very challenging for us, but it's also very challenging for the computer vision or camera-only system. It's because of the dual systems and the multi-sensory systems we have that we can go determine that. Another thing here is radar. It's another sensory type that we have. It's a radar-centric perception. Why is that something we invest in? It's because of the fact that radar actually addresses a lot of the blind spots that we all have, which is in some of the weather condition or low light condition or challenging situation where the camera has something interfere with the images. Radar can still read the signal. Now, mind you, here on the left-hand side, this is how a point cloud, where you take a data at one section or a static environment and try to interpret the world. Obviously, it's challenging for us because we're not bats. We don't see the world like bats do with radar and so forth. And this is the scene that you have here is actually capturing what is seen in the camera system in the middle. The thing that's challenging with that is how can we get data from both scenarios and fuse it together to have a better understanding of the world we have around. And then also using ML, identifying patterns of how people walk or how animals behave to understand what they are, and then start having definition, real classification, real time, in order to go address that. So, digitalization is not just about using digital tool versus manually driving the cars in the scenario, but all of these scenes, we can reproduce it, combine the different scenarios in order to see how our software, our advanced safety software products, or the signal perception system can interpret the world around it. And this is something that can be done dynamically. One of the key benefits of all of this is think about how long it takes and the logistic and the cost to have a vehicle, like literally the same vehicle, shipped around the world and driving 1,000,000 miles, right? What if there's an issue that happens? You unexpectedly hit a pothole and have to have damages. the whole plan gets interrupted. You can start simulating that beforehand. And let's say during the million-mile drive, you find that an error happens. That means you have to go back to the drawing board to go review what the situation is, engineering designed it, and reproduce and start doing the manual testing associated with it. Versus with the simulation that I showed before, here, you can start testing out all those scenarios in advance to be that much more confident about the software stack and the capability of your software better than ever before. Because I do realize some of the OEMs still require actual road drives and road trips before validating the performance. But instead of waiting for it and having the less confidence of your performance of your system, you can do that with the highest confidence by leveraging simulation. Another thing that I have found is that with the simulations, we've been able to, instead of having multiple hardware products, you know, as you can, how many people here are in automotive specifically? Okay, I'm gonna have to ask some questions here. There's some of the individuals here that are not in automotive. What industry do you represent? Okay, so software industry wasn't one. Somebody back there? What industry do you represent that's not automotive? It's software, so a lot of software. So the key thing here is that in addition to the software testing, because automotive and cars are a physical entity, we have to understand what that scenario is. And as you know with software, to try to test all of that manual and you don't have the hardware infrastructure or the vehicle infrastructure is very challenging. So how can you use software environments, virtual environments? How can you leverage simulation environments in order to better understand your software performance or the bugs that you just fixed for a customer? Can it be simulated so you're that much more confident? So instead of waiting days and weeks, you can, within a simulation environment, test it out in less than 30 minutes and release the next version in the next release slip cycle that's needed. So I see more and more of this happening at a faster rate ever than before. It's not about whether there'll be change, it's the velocity of change that's really being addressed here. And the digital systems and techniques that I've spoken today gives us a lot more confidence to be able to do that, because we're talking about autonomous vehicle. These cars that are, weighs a ton or so, or half a ton, that can have significant impact. And our goal is to really be focused on that safer, greener, and connected vehicle. I want to make sure to also give time to ask questions. Obviously here in Aptiv, I'm very focused on autonomous vehicle and cars, but there are obviously other industry backgrounds I've done leveraging AI, whether it be Apple, Google, and Microsoft. So that's the end of my presentation. And is there any questions to ask?
In AI, we talked about what is the efficiency or
Yeah.
how good your algorithms are, or how good your so if you're simulating a scenario, for example, let's take a pothole, car going over
Sure.
or in a rainy scenario, and so in a simulation model, what percentage of the real world, and is there a feedback loop that you have that as you
Yeah, so we have the capability of something called hardware in the loop, software in the loop, and vehicle in the loop. So any of the, whether we are, because at Aptiv we provide actual hardware by itself, software by itself, or combination, and where it's like simulated in a vehicle. All of those capability is enabled in the simulation environments that we have. There was a recent article from the National Highway Safety Association about a child and a vehicle was not able to register a child. That's not a scenario you can ever reproduce, right? But that is a reality of the environment we all live in, that people jump up unexpectedly, kids more than others, right? So how can that be simulated? That is something that all those situations you hear about, whether it's accident or not, or the testing, whether it's a national highway or not, those scenarios are actually reproduced in a simulated environment for us to then test it out. Okay. Because there were blind spots that other advanced safety vehicle and advanced safety technology did not meet or didn't, because of the system, We want to be confident that we can do it. And then you asked a question about the confidence level of the results and so forth. We have been able to do the simulation in a way that we get the validation and acceptance from our customers. So pretty high if it means OEM acceptance. Now, do they have, in addition to that, additional road testing? I think that is just where we are with OEMs and car makers, but that doesn't mean that our data and simulation directly correlates to that, and then some. So the anomalies are the ones we do exceptionally well, and that gives them so much more confidence in our advanced safety. Thank you so much.
So Sophia, you were talking about ADAS and AD, which is the future of the automotive industry, and we all know that in autonomous driving specifically, it's about handling data. You have 23, 25 sensors in a typical autonomous car producing 2 GB of data every 5 seconds.
Right.
And OEMs, be it OEMs or tier 1s, I mean, they were happily either assembling, a car or they were manufacturing, but they have never dealt with handling this volume of data. So end of the day, it is about your ability to handle this kind of data, which are very, very few companies, let's say, like Ubers of the world or
Yes.
Googles of the world or Facebook of the world, have done it. So essentially, it is about tier 1s and OEMs becoming tech companies.
Yes.
So 2 questions to you. As a tier 1, how are you transforming, how is Aptiv transforming itself into, making that transformation from being a manufacturing-oriented company to a, tech company? And how do you see OEMs doing it, and how successful are they?
Thank you for the question. Both parts, too. So number one, Aptiv has been a tech company, and we actually invested in electrification early on, which is one of the reasons why we are a key customer of the famous customer that cannot be named, right? And so part of it is understanding the strategy and the meta trends that I shared out, amongst other things, that we do that deep dive. The data that is leveraged is not just in the products we have, but it's how we operate and how we think about doing things, which is one of the reasons why electrification was something we invested in. Before it was sexy, before all the rules happened to really incentivize electric vehicles. But then also with advanced safety and so forth, it's not just data that matters. Data quality is more important than ever before. Think about yourselves. When you look around the world, do you pay attention to the leaves fluttering in the background? Now, if there's a tiger in there, yes, you should definitely pay attention. But that's not the case. There are ways to optimize the system using understanding of other systems that we have, right? I've been very fortunate to work at Apple, Google, Microsoft. All of them had to work with big data, right? One of the reasons that Aptiv was very attracted to how we're thinking and moving forward is how are we leveraging AI, not just in the end product, but how we do things. How do we consider this scenario? That's number one. And that's one thing that we are exceptional at, not only in the simulation. That is about data. How do we use data that we've collected, make a virtual world that simulates it so we get the best understanding of our system, so we could be that much faster than ever before. Another thing is that we have simulation services that we actually provide post-SOP to the OEMs themselves because of our capability. Same with our ML capability as well. So that is data. It's something that is not just in the design, but even afterwards, after production, is something we're best in class in. Secondly is OEM. OEMs have different strategies, as you already know, around how to go leverage data. Understanding that environment, how to optimize it as quickly as possible to directly have that digital feedback loop is incredibly important. And the reason is you don't have to wait for a recall. You'll know it's going to happen before that. And can you take preventive action around that, right? If there's warranty issues or so forth, can you actually send that information? That's like billions of dollars right there that's been happening. Can you go address that and then actually state that the 30,000 miles for the next Toyota or other vehicle maintenance, these are other things to consider to reduce the risk. Those are things that are opportunities. OEMs have their own strategy associated with it. Obviously, they're partnering with Tier 1 that also have strong technical background like Aptiv. Thank you.
My name is Chandra. The systems that we are building are all heterogeneous systems, right? So being a tier 1 company, you kind of take the semiconductors coming from various other semiconductor manufacturing companies, and when you are integrating and making a system around it, maybe a powertrain system or an ADAS system, whatever it is, if there is a fault that is occurring in the system, it may be deep down in the device level as well. What is your acceptance criteria you pick from these semiconductors?
So you're asking me to share out my semiconductor strategy? I think we should have an offline discussion if that's the case. Semiconductor strategy, especially nowadays with some of the semiconductor constraint, is something top of mind with anybody that leverages that, whether it's mobile, data center, and automotive, right? So our strategy is about what gives us the best opportunity to showcase our technology and the product portfolio that we have. And there's obviously multiple attributes we consider in that analysis, both in the semiconductor situation and environment and the technology node that is present, as well as the technology we need for the products, the active products, to be successful in the market. So there's aspects of that we consider. And then what are the synergy across the various products? Because another gentleman here spoke about is the car is getting consolidated in aspects of it. First of all, the cost of wiring. I don't know if you ever saw one of the wire harness to get in a car. It literally is like our nervous system. And by the way, the nervous system can go around the world, like if you do end-to-end, all the various points. And so reducing some of that complexity is key. Electrification is one of the EV systems are key to that. And semiconductor is not something we just consider individual, but what is the overall system and how does that take into account how it shows up. You may have the best, let's take an example on a phone. A colleague of mine were talking about the phone and how there was another phone that had a better camera technology than the iPhone. And yet the iPhone had better performance in the market. Do you know why that's the case? It's because Apple really understood the use case of the phone. It's not only about the best chip or the best technology, the hardware itself, but how that's leveraged in the use case that it resonates with the customers. And that's all of us here, right? All of us who are car owners. So the reason why is iPhone really focused on what is the most adaptive situation for most iPhone user. A friend of mine has twins, and they had to try to take pictures. Do you think you have time to go focus, really get it steady, to go take a picture of your kids? No. The thing is, how can you have a phone come out, have a button for the camera, and then image stabilization happens to really capture the moment? It doesn't matter after that moment passed if you can take a great picture, or because your hand is not stable because you're trying to take a picture, that the image is blurred. You did not meet the essence of what the user wants. The user wants that picture of their twin boys, which is what my colleagues had. So in this case, is how is semiconductor, back to the question, how does semiconductor is one of the components that's needed for us to surface the best advanced safety, cockpit software, middleware DevOps solutions that's needed from compute to perception system. Thank you. Any other question? Thank you very much.
Hey, so that was a great session by Sophia. She certainly gave us a peep into the emerging tech or the future tech in the context of digital engineering. She gave a case study of collecting millions of data points and how then they are being simulated using AI, deep learning, and all of this will help in finally creating products which are more safe, more green, and sort of more connected. And I guess she certainly created a lot of energy in the audience, and you can see that by the kind of questions being asked by the OEMs and the opportunities the OEMs are seeing in it. So all in all, great show. And yeah, so Karan, Thank you so much, Sandeep. And if I could just add to what Sandeep just said, right? So we're seeing that digital is proliferating every aspect of business, be it products, processes, plants, people practices, right? And while this is happening, we are also seeing an increasing complexity. And the way to address complexity, in fact, becomes digital engineering, in fact, becomes the way to address this increasing complexity.